So this zero grid kinetic generator and fitness machine, whereby it's a multi-purpose machine. By the time you'll be pedaling, you'll be doing some exercise, and in the pedaling motion, that exercise won't go as a waste. It will be later transferred to the flywheel, whereby in the flywheel section, there will be a speed up, which will help in rotating the chev cutter. And that the chev cutter section is where the napier grass will be cut into smaller particles. And there, the chev cutter section, we've got the rack and pinion mechanism, which helps in pushing the napier grass in front easily without the help of anyone. And on the other section, we've got the pulverizer section, which helps in mixing down the animal feed mixture, and it will help you find the right product for your livestock. And on the other side, we've got the gym section, and I can show you how it works. So here, the gym section, it will help you to stretch your arms. So that's all about the zero grid kinetic generator and fitness machine. That's why I call it a multi-purpose machine. Let me show you how it works as I pedal. So you can see, by the time I'm pedaling, the energy doesn't go as a waste. It helps, it is later transferred to the flywheel, where the flywheel rotates and helps the chev cutter also to rotate easily, which helps in cutting down the napier grass to smaller pieces. And there's the chev cutter section. You can able to see the napier grass coming in front easily without the help of anyone. So there is where the rack and pinion motion mechanism works. Yeah, that's how it works. Thank you. To clean cooking.
In Evans, Nyakach TVC. Here we have a 3-in-1 furniture. It entails a bed, a chair, and a table. As from now, it is a chair. If we remove this part,
so I want to recognize robotic team today. I don't want to recognize you.
Now it's become a table. If you unfold it,
the people now are remaining with the research coordinators. Initially, I would have requested the research coordinators appear what I have. I don't know whether they're here or what they have. Research coordinators
now it becomes a bed. Yes. So we can unfold it and fold it again. If we unfold it, we unfold it.
He has always been number one in research. Ukisimama unapata scope because they are consistent. And I think the react should be there to reward you for that. Then
now it is a sofa set.
That's the registrars.
Yeah. Thank you.
Here we have come with a project, of which our project it's called Solar Sodas Poultry Brooder with a heat regulator. So in our project, we have come up to build a brooder, of which it comes with 2 walls. We have the internal wall and the external wall. So in between the walls, we have placed a sawdust so that to retain the heat that has entered the brooder. So in the brooder, if you come, you can come here and you can just come in front of it here. You can if you come here, you can see the plastic around it to prevent the ticks that have entered in one corner, for them not to die. Then we have the solar system now that help us produce our heat. So we get our source of heat from the sunlight. Then from the sunlight, it goes direct to the solar panel. From the solar panel, it goes to the solar controller. From the solar controllers, it goes direct to the battery. Then, because of our bulb, it uses a lot of heat. So we have come up with the inverter to help us to light that bulb. So we have also the regulator that help us to regulate the temperature that is in the brooder. So on this regulator we have a sensor that sense when there is a hot, it sends and switch off automatically, and when it is cold, it sends automatically and switch on. Yeah, then we have this roof of which it is being raised upward so that to prevent moisture from getting into the brooder. Then there is also the ceiling board around it. That one. And for the air circulation, we have now introduced the ventilations around it. Then from the ground, we have raised it about 1 meter from the ground to help the moisture that are on the ground, or maybe the run of water running, to prevent it from being attracting the brooder. I think that was our project, and I think it will be helpful because when you look at the strategy on cold areas, you see that there is high death rate of chicks around those areas. So we have come with this project to help, and also to help in the production of food, and to encourage the farmers to practice the poultry farming. Okay. Welcome to St. Joseph's electronic project presentation. So here we have smart bin for garbage collection and toxic scent elimination using solar energy with the surveillance system. So here we have the solar that helps in charging of the battery that is supposed to be used at all times. So this one is going to be reliable since it is just relying on the solar energy. So as I will show you how it works. When it is powered using the switch, the bin is supposed to be programmed to automatically open and closes by itself, and it has a sensor that will sense when somebody is at that point that wants to do the dumping, then send a signal to the mega, at which at this point is where the programs are done. Then if you switch on, it is trying to open, but we have a challenge with it, so it will just be somehow drifting, trying to indicate the process of opening and closing. All these are programmed, and it's supposed to be doing the work automatically, not that somebody will be at this point opening and closing the bin. And at the time the bin is full, we have SIM 800 that is supposed to be inserted at this box, but at now it is not inserted. That is supposed to be sending a signal or information to the person concerned in charge that will come to empty the bin. Inside the bin we have infrared component that helps in drying the wet garbage. That is this the infrared component that helps in drying of the wet garbages. So with the help of infrared component, this one helps in elimination of the toxic scent I was talking about. The toxic scent will be eliminated since the infrared will be drying, will be doing the drying works of the wet garbages.
Oh, nianze na shule. I come from St. Joseph Technical for the Deaf, and here we decided to make a jiko that uses used oil. Used oil, this one. So this used oil, unaweka hapa. Hii ni tank of 2 liter. Tank of 2 liter. Hata hii unaweka hapa ndani. And then we have a tap here. This tap is to regulate this oil yenye inaingia huko ndani. So for the combustion to take place, there must be oxygen, and then that oxygen is we use this blower to generate that oxygen we need. So oxygen inaingia hapo, and then ikikutana na used oil inawaka. And again, if you don't have this blower ama una steamer, you can still use this solar, and we have a battery here. So for the solar part, we have a fan here and a funnel here and a fan. So you remove this, you insert this here, and then you put this one. So solar ina charge battery ina generate power hapa, alafu hiyo power ina run this nini propeller, then it generates oxygen that we need to make the combustion on. Yeah, that's it. And again, advantage of this, it cooks faster. A normal water goes for 15 minutes, and this one of ours, you can boil that water within 7 minutes and it's well. Thank you.
In our community, we do have a problem. Now there is mining of gold, and after the mining of gold, there is the production of the huge heaps, the cyanates, as we call them back at home. Now, those cyanates do pollute the environment as they contain a lot of mercury after the leaching. We thought of how we can use the mercury and make them useful, and came up with a way by turning them into blocks, as this one over here. Now, the thing we do, we take the cyanate, mix it with some chemicals, or with cement, not chemicals, and put them over here. Now, after putting it here, you do take it. This part is very movable. You take it, and this machine comprises of 40 of different parts. There is this electrical part, the motor. This motor produces the pressure, which can be used to, you see there is a cylinder over here. Now the cylinder compresses this one. It can produce up to 30 tons of compression. Now, as you can see, this is a prototype. It's very strong. It comprises of the cyanate and the cement itself. As you can see, I can even drop it. It doesn't break. It's a very strong block. Economically, it's also cheap compared to the other blocks. This one is just a prototype. There are very many different molds, and as you can see, this mold is the standard size, 15 by the 7. In a day, you can produce up to 2,000 blocks using this machine. Now, the working, after mixing the cyanate and the cement, you put it here, and then you swipe this. This part is very movable. After that, you close it over here. You see, it's very lockable. And we have the lever, which can be used for compression here. So after pressing this, it will compress this one. As you see, you even have the gauge. This part, you have a gauge. The gauge will show you like the compression. It will play of 40 to 60. It will compress this one. It produces much compression compared to the ones which are produced using the manual labor. Meaning our blocks are very strong compared to the normal ones. And after the compression, you just press the button and it will come up. Now, as you can see, these ones are for interlocking blocks the way these ones are, meaning you can build a structure without using cement at all. By just interlocking the blocks, you're adding one, putting one on the top, making it very economical. Or if you want the normal blocks, you can just add, we have the plates over here. This one is for the interlocking blocks. You put them here, and you have this one is for the normal blocks. Just put it over here, and it will produce you the blocks. Here we have the hollow ones. Yes, this one produces the hollow blocks. We can be used maybe in the layers of a story building. Now, this project of ours, it reduces soil pollution back at home, and also the mercury, it goes to the lakes back at home. So when you see those areas where there is the gold mining, there is no fish in the lakes. Why? It's because the mercury is killing the fish. Now we're making a way of using the cyanates to make them useful and making it very economical. Thank you.
Okay, my name is Simpoli Kapoweno from Ramogi Institute of Advanced Technology. Here we are here to exhibit. We are doing research, innovation. We have a project here called Smart Trolley System, and this trolley is used to make things easier for those who are doing shopping in the supermarkets, so that as you do your shopping, you can confirm all your bills, everything you bought confidently without going to the cashier. So here, as you do your shopping, every trolley has its own system. You have to confirm what you bought, how the cash you're going to pay, or the amount you're going to pay, how you're going to pay it, either through cash, through card, through M-Pesa, or any other way, or through pay bill also. Then here we go. As you pick things out, as you pick your items, you must scan the barcode for you to see the price of what you are buying. So here, let's see. I want to start with this. I've picked a yogurt. Now, I want to pick yogurt. So I want to confirm the payment. You just confirm the barcode. So it is yogurt written. I've picked one. Or if you want to, you just do it the same again. Then you go to, this is sugar. You confirm sugar. That is sugar price written there. Or if you want to, you can just swipe again. Then it reads. It writes it there. Then you do your payment. You do your payment now. So you decide, are you paying through M-Pesa, are you paying through card, or are you paying through cash? You see? So here, let's use a card. We have a card. Let me pay through card. Then you confirm your card. You see? No, use it the right way. Good. Just confirm the card. Then you pay. I think okay. With it? Okay. Good. Now you have your receipt there. You can confirm your receipt. The same receipt goes to the cashier. Goes to the cashiers. The same receipt you have it for confirmation. So as you go out, they check what you bought. Thank you.
So I am Penina Christine from Siala TTI. This is an earthworm sawdust water heater. The earthworm sawdust water heater, it uses sawdust to heat water. So we'll take our sawdust and put it up here and lit our fire, and the fire will go through the heating chamber. So the fire from the heating chamber will transfer heat to the water inside here. This tank has insulin materials. The insulin materials include clay, ash, and wool, which are poor conductors of heat that will not allow heat to get out of this tank. To mean you'll be having hot water the whole day for any time, for any use. These are cold water inlets that will pour our water inside here, and this is a hot water outlet. As you can see, the water is hot. So it enables us to use hot water at any time of the day. Yes, thank you.
Why project yet? The theme, the title of the project is Green Flash. Green Flash. Here we have a tank here. Then the tank that we have, we can use it to harvest the water. The water that we are using here is water from the rooftop. Then that water we can use it in many purposes. Lakini we have decided to use it as a piece of it. This is our project. Pia tumekuja na mbinu nyingine mpya ya kuweka kazi kuwe rahisi. Sasa tuko na cistern, alafu tuko na water closet. Sasa tumetumia ile kifuniko ya cistern ikuwe kama wash and basin. Yenye mtu akitoka pale, mtu akitoka akikuja ajisaidie, then ataflash maji. Na badala ya kutoka hapa aende pale kwa kona aenda nawe, atakuwa amefanya nini? Ananawia hapa. Sasa kazi kuwe rahisi. Yenye tunajaribu kutengeneza ni hapa ni ile maji yenye inatumika pale kwa water, tunatumia hapa ili itumike tena kwa system, isiende waste. Kuna zingine advantage za hii project yetu. Advantage ya kwanza, na ile masaa mingi ya kutumia ukitoka kwa nini, kwa kujisaidia, unaenda pale kunawea huko, hiyo tunapunguza hiyo masaa. Unanao hapa na ndio unajisaidia alafu unanawa hapa. Ya pili, hapo nyuma 2019 tulisikia wakati wa corona kunawa ilikuwa mingi. Kana nataka ile usafi hygiene, maintain hiyo hygiene. Hapa tumedecide tuweke hii kitu juu tu. Theme ya leo ilikuwa kuleta kesi kwa leo, transforming tomorrow today. Ndio tunajaribu at least ikiingiana tutakuwa tumerahisisha kazi kwa siku zijazo. And then mpaka hapo nitakuwa nikiulizwa maswali nitakuwa ninajibu.
Hii hapa tunaweza tumia kama floor tile ama wall tile. It is made up of broken glasses. So first of all tunaenda kwa gabions ama sites, tuna collect hizi glasses. After collecting them we wash them. After washing ndio zikuwe clean. Then unaona hapa tuko na smaller particles. So tunatumia tools zenye tunatumia kuzi crush ni mortar and pestle. Ndio tukuje na hii zikuwe ndogo ndogo hivi. Then after umeziweka kwa hii tray yako, we mix these two reagents. This one and this one. So tunatumia hii kama one full bottle. We mix it with the one bottle of this one. After mixing, if you want to come with the different color like this one, you can add the paint. You mix them with paint. Then after that, you spread it to your mold. You left it there for in a room temperature. Unaweka for 1 hour 30 minutes. Ndio ikuwe dry. Then you to come up with such tiles.
My name is Collins Jack. We are here to present a project for you. Continue. Your name. Okay. The project is all about flameless cooking technique. It involves two things. That is the mode of heat transfer and reflection of light. That's the principle. Okay. This project here we have the concave reflector. Then we have the sophria used for cooking. So we use the sun rays to cook from the sun. So when the sun rays strike this concave reflector, they are made to bounce back to a point. When they bounce back, they converge in a certain point they known as the focal point. And the focal point is where we place this sophria used for cooking. Okay, that's all.
Okay, I'm Sabina Kumonyango. We are with Joseph from Bondo TTI, and this is our research. It is under textile innovation. Here we have the duck down, and the duck down is used as the same as a cotton wool. And the main reason why we came with this research, it is because we want to supplement the textile industries with the raw materials. You find that during global heating and during the dry seasons, you find that the cotton wool farms are being affected, leading to low production of the cotton wool. This duck down is only produced during the brooding of a duck from the first day to the 28th day, and it is produced naturally. Yeah, thank you.
Okay, so here we have our main switch. When it is on, the motion sensor is detecting motion. That's why you are seeing it lighting and going off. There is motion around here. It's being detected. And again demonstrate this. When there is darkness, can you come and show movement here? When there is darkness, move it closer. When there is darkness and there is approach, you can see the security light goes on. And here we only need 33 degrees Celsius for the fan to go on. So they work automatic. Here we have Ecolango. Ecolango controls your entrance. Ecolango controls your impact. So here we have a door. Our door is being controlled. The entrance is controlled through a fingerprint sensor. Our fingerprint sensor only allows the authorized to get in the house. Then here we have the Lord, which is the lamp. We use it to light the house during the day and the night. So here we have a motion sensor. Motion sensor detects your presence in the house. So when the door is unlocked and motion is detected, this light will go on. When the motion is detected and the door is unlocked, it will be on. But when the door is locked and no motion is detected, it will go off. So it helps us in saving power wastage. Again, here we have the security light. Security light is being controlled by the ultrasonic sensor, and again it's being controlled by the LDR. So security will only go on when it is at night and approach is detected. It will automatically go on. Then again, here we have our flame sensor. Flame sensor goes in hand with the buzzer and the door. When flame is detected, which is a fire, then the buzzer will go on to alert you that there is a fire in the house. Then the door will unlock automatically. So when the door unlocks, you can easily go out, which means that will now help us in safety, because when the door is locked, you can get harmed with the fire inside the house. Again, here we have our fan and we have our DHT11. It will detect, it only detects temperature and humidity. So it will detect temperature when it is above 30, fan will automatically go on. When it is below 30, fan will automatically go off. So we are trying to solve the problem of power wastage. We are trying to maintain security. And again, we are enabling customer to make good decision, because this our system is even controlled, is even monitored through a remote way using an app in the phone. So it will give you an easy way to control your power consumption, give decision, and even it is a smart way of maintaining security in your house.
Okay, so the title of this project is a Geoscada, that is a smart and revenue water detection system. The main aim of this project is to detect where the problems of the lost water are occurring. Let's take for the example, we have leakages. We may have leakages along the line and even burst on the pipes due to high pressure or even when they are old. Again, we may have illegal connections along the line. So we have introduced our components here. We have included these components, that is the flow sensor and the pressure transducer. So the flow sensor will detect the flow of water, while the pressure transducer will now convert that pressure or the force at which water is moving at to electrical signal. Then it will send it to the system through the Arduino that is connected to the system. So we will be seeing the problem that has arisen along the line at the computer or our software. Then again, this system is also connected to GIS. GIS is a geographical information system that will tell us the exact location. It will provide the map and tell us the exact location where the problem has occurred. I think that's all I can say.
This is a plasto building material made from plastic, sand, and an additive. These additives are epoxy resin for adding the binding process in it. It increases the binding for the sand and the plastic. The process is just to melt. We collect the waste plastic. We melt it within a range of a high heat to produce this one. After melting them, after we have melted them, we add some sand within a ratio of 2 to 1. 2 units of plastic, a molten state, and 1 unit of sand. These units, we use the method called volume batching method. The container which we used was labeled and was given a volume, which we used and produced this one. In the process, we could save the environment by using waste plastic rather than picking this plastic and going to dump them in a waste site. we allianced with the waste collectors to give us the plastic. We heat them and produce these useful products.
Okay, we came up with this project of plaster building construction material is to solve the problem of tomorrow, today.
By collecting the waste.
By collecting the waste from the dumping side, blocking drainage, and we are using them to mold building materials. And as you see, this is a very decorative material, and we have painted it to confirm if we paint it, will it be in a good condition? And here is it, very aesthetic. And the process continues by collecting even a fuel. We collected a gasoline fuel by condensation process, and the fuel is used in generators, and it is used even in driving electricity machines. And that process is called pyrolysis process. So
yes.
Thomas Achacha from Nyando Tech TVC. So this one is hydroponic farming, a smart one where we use farm waste, and it is also called bio hydroponic. So here we use this waste to get the nutrient for this our plants, and this system, it is automated. So this pump is attached to a timer. So it pumps at an interval of every 2 hours for 5 minutes only, then it stops. So it saves water because the excess water is being recycled back to this reservoir tank, and the same water now can be channeled back to this our plants. So the unique part of it, Nyando is a rhizome area. So this one is a waste where we are coming from. So we have converted this waste to a plant media. We carbonize this waste, we burn it under control oxygen. Now we have this plant media from this waste. So plant media normally for hydroponic are being imported, but we thought it wise that imported plant media is very expensive to farmers. That's why we came up with this waste. So we carbonize it and we get our locally made plant media. That is all. If there is any question, we can take. Thank you. And we also have our research coordinator here with us. She can say a word. You can. This is our research coordinator, so maybe she can also tell you more about the innovations that.
Teresa Uma, a research coordinator, Nyando TVC. We are here for the Kati Lake Region Tivet Fair 2026 with the main aim of promoting the bottom-up agenda. Our theme rotates about achievements of the bottom-up agenda. So that is the main thing. So as Nyando, we are here to work on the agriculture bit, which is about food security. So here we have a smart format where we can do agriculture. We're coming from a flooded area. Now we are working on a raised farm, so that even if the place is flooded, at least we have a raised farm
where we can do the farming even with the floods. And then we are also making use of the locally available material, which is the rice husks, which we are using to replace the soil, together with the nutrients made from the waste of the locally available food. Basically, that is what we have today. And we also have a smart garage that is based on AI that does diagnosis. That one is, unless we go to the computer to show you, it's a smart garage system that does car diagnosis using AI. So those are the two major projects we have today, alongside the skills which we completed yesterday. We had skills in food production, skills in ICT networking. We also had a skill on hairdressing and beauty therapy. Basically, that is what we have as Nyando TVC for the Tivet Fair this year.
Very well. Wanaweka mbele to defend the position. Then tunajua sasa here tumeanguka because now this thing is not owned by the trainer.
Nicodemus Miriaba, Principal Yamo TVC, Kisii County.
Robinson Kambi, Principal Rogare TVC in Kisii County, Vice Treasurer, Red Region.
Beatrice Nyareki, Principal Maberas TVC, Migori County.
My name is John Mareri, Principal Kitutu Church, Kisii County.
Martha Waga, Principal Rangwe TVC, Homa Bay County. Coletta Omondi, St. Joseph's Technical Institute for the Deaf, Nyangoma, Disability Representative.
I'm Kawala Joseph, Principal Riatirimba TVC in Kisii County, and I'm also the Chairman of Research and Knowledge Management, Lake Region.
I'm Linda Buena, Deputy Principal Academics, Omuga TVC, representing Mr. John Owoko. Lea Gore, Deputy Principal, Siala Technical, representing Madam Asha Bakari, Migori County.
I'm Soy Rosemary, Principal Nyando TVC, Kisumu County.
I'm Jessica Mhonja, Deputy Principal in charge of Academics, Ugunja TVC, representing my principal, Mr. Thomas Waga.
Thank you, our principal. Can we clap for them? We want to appreciate you even as you sit down. Without you...
Okay, good afternoon, members of the press. I am Tom Olango, Director of Vocational and Technical Education, responsible for research, innovation, and data management. Today's event is very important to us as a ministry because it is a way of celebrating innovations and skills competitions for our learners. So this is something that we always do on an annual basis, and it helps the learners to really improve in terms of coming up with innovations that are useful for national development. Yeah, this is a gospel that we always preach, and we'll continue preaching it because Tivet has become a game changer. Because if you go to our learning institutions, we have shifted the way we are training learners in a manner that we offer them modules. So immediately after the modules, they gain a skill and are able to join the labor market. So I would wish to encourage all young people who are out there and have not joined our Tibets to seek admission, because what they are going to get out of our Tibet institutions is going to be lifelong and will help them, live in the society by way of fending for themselves.
Okay, what next after you?
Yes, after this we are going to have the National Tivet Fairs that is going to be held in Makueni County at one of our institutions called Water Technical Training Institute. So once that one is done, we'll get our best performance, whom we intend to take to Wajir County to take part in the Education Week, which is a build-up activity for the Madaraka Day national celebrations. So there's a lot to be done after this, and we want to believe that those who are going to, perform well here, they are not going to sleep because there's still a lot to be done in terms of, the type of other competitors that are going to meet ahead.
Can you talk about the innovations and the linkages to industries?
No, what they are doing actually are industry-led, because for now we have introduced dual training, where our students spend a minimum time in the classroom, but a lot of time in the industry. And as such, whatever innovations we are seeing they have here today are actually industry-led, and also have a lot of support from those whom we refer to as the industry mentors. So I would want to say that is a very, it's a strong linkage that our Tivet institutions have with the industry, and it's good for us so that we train skills that are required by the industry. In the past, we've had a situation where there was a disconnect between what is learned in the institutions and what is required by the industry. But in the current dispensation, we are together. The industry is working together with the learning institutions. So whatever you are seeing here, there's a lot of industry presence.